The Inverse Square Law, presented to you by Team Falcon, Darren Jolly, Daniel Knutson, Jason DeHaan, and Trace Davis. Section 1, September, Instructor, Raul Vargas. Team Falcon will demonstrate the inverse square law to the best of their ability without testing in a free field. In layman's terms, the inverse square law is simply understanding that the closer you are to a sound source, the more intense the sound will be. In fact, this law provides us with a constant, and that is if you cut the distance between you and the sound source in half, the intensity will increase 6.02 decibels. This also applies and vice versa. Team Falcon used a Mojave FET 210 large diaphragm condenser microphone, a JBL 2300 speaker monitor, an iPhone 5 running the 10th decibel application, and a tape measure to accurately capture and record the experiment results. Now let's get on to the testing. Test 1. We will be producing a 1 kHz sine wave with an amplitude of 100 decibels at the sound source. 6 feet away, we will place our decibel reader and record our findings. Let's crunch the numbers and see if we can calculate the increase in intensity if we were to cut the distance in half from 6 feet to 3 feet. Applying the inverse square law, the new level will equal the sound reference, which for us is 75 decibels, plus 20 times the log of our reference distance of 6 feet divided by our new distance, which will be 3 feet. Following our order of operations, 6 divided by 3 equals 2. Now let's take the log of 2, and that comes out to be 0.301. Multiply 20 by 0.301, and surprisingly, we get 6.02. We will now add that to our reference sound of 75 decibels, and we get our expected sound intensity of 81.02 decibels at 3 feet. Now let's run the test and see what we get. Under the same conditions as test 1, we will take the decibel reading of our sound source at 3 feet away. Let's compare the results. As you can see, we are very close to what was to be expected with our calculation. Our decibel reading for test 2 was at 80 decibels, and at one time actually peaked at 81 decibels, which is an increase of 5 to 6 decibels of intensity. Listen briefly to see if you can hear the increase in intensity. Understanding that we were not able to test in a free field, we are led to believe our tests accurately represent the inverse square law. The inverse square law can be used by professionals in the recording industry to identify the ideal distance between the audio source being recorded and the location of the recording device. If you are looking to provide depth within a recording and do not want to achieve this effect by using software plugins within your digital audio workstation, you can simply apply the inverse square law. Engineers will increase the distance of the sound source from the microphone, capturing a natural sound of depth. A mix within a recording can easily achieve depth as well by understanding the inverse square law. By adjusting the intensity of your tracks, you will create individual spaces for those tracks to lie within the recording.
Reluctantly crouched at the starting line, engines pumping and thumping in time. The green light flashes, the flags go up. Churning and burning, they yearn for the cup. They deftly maneuver and muscle for rank.